So let's continue talking about epoxy-anhydride curative systems and really the need for proper selection of accelerators. In some cases, maybe you can put together systems that function fine without accelerators, but let's talk about the importance of selection. Let's begin with whether or not accelerators are actually necessary. So Jeff, speak to that.
In general, anhydrides can be cured simply by increasing the temperature to the temperature that it cross-links at.
For sure, yeah.
I mean, you don't need an accelerator to make the reaction occur. But if you have limitations in the temperature at which you can achieve, the properties you want the finished product to have, then an accelerator is going to be required.
I mean, you could do like a thick mass casting, accelerator free,
right.
Nice slow cure cycle,
Exactly.
gentle, so that fits the bill. I understand that.
Sometimes if you want to cut down the processing speed, like like you alluded to, Boris, then you use an appropriate catalyst.
Yeah, now we're talking about pushing the envelope a little more. Yeah.
Process
Yeah.
time, and within catalysts, the anhydride epoxy chemistry actually has two kinds of catalysts in general, two categories of catalysts. One is generally called active catalyst, the other is called latent catalyst, and the difference is that the active catalyst cannot be pre-added to the anhydride, because if you package it with anhydride, mix it up, it'll actually start to react
Yeah,
with
makes
it within
sense.
that.
Yeah.
The latent catalysts are stable as a mixture with the anhydrides, and they are used in many of the applications where you just want a two-part system. You have epoxy resin and an anhydride-curing agent, which has the catalyst built in. Different processes will use different category of catalysts.
And that becomes important when you're doing processes such as open bath protrusion or filament winding, where you need that open pot life at ambient temperature.
Certainly.
And then you activate the catalyst at the right, that becomes part of the cure cycle or the process cycle. And then again, whether it's a composite application or some sort of an encapsulation, you have the choice of the catalyst then becomes important as to which kind of accelerator that you use in the system.
So in terms of choice, do you want to take us through what are the typical go-to ones that every formulator would pick, and can you speak a little bit about some of the things that we included in the study that we worked on together?
In general, there are, by way of classes, you have the tertiary amines, you have the imidazoles,
Substituted urea.
Substituted urea that you can then use as accelerators.
And the nice thing is that, we've uncovered some typical things, and maybe we've produced data to kind of substantiate or to confirm that. And then in some cases we found a couple of curveballs, which was kind of nice.
Interesting.
That allowed us to look at some new systems.
New insights into this whole.
Absolutely, that was definitely the fun part.
Yep.